In this video, I want to quickly go over AP style of FRQ problem that goes over some stuff that you learned in chapter 7. So we'll just quickly label this or title this Q3 Day 21 Chapter 7 Review. So this is from a practice book that I have, and it is problem number 5 from the FRQ, free response questions. So this is no calculator. So this is a problem that you would see from the no calculator portion. Now, notice how 5A you guys should easily be able to do. It says a function y equals f of x satisfies the differential equation dy over dx equals 1 plus x squared over y. A, on the axis provided, show the slope field for the given differential equation at the 11 points indicated. So like I told you in class, they will always indicate what points they want you to create the slope field on. So go ahead and do that. Pause the video, and I want you guys to do that right now. So you should copy this in your notes, 5A, B, and C. Leave enough space, or maybe do it one at a time. We're going to do it in order. So right now, pause the video and do 5A. So after you've created your table for these 11 points, you see you get slopes of either 1, 2, undefined, -2, or -1. Okay, and it all relates on the points that we have. So after that, we're going to go ahead and plot these. So again, or we're going to do the tangent lines for these. So go ahead and pause the video. You guys do the tangent lines and check it with mine. So remember that the key here is that your slopes of 1 and -1 should be what you're kind of basing yourself on or using as your guide. And then make sure that the slope of, for example here, slope of 2 is steeper, significantly steeper than what the slope of 1 would be. Okay? So you don't have to write m equals 1, m equals 2 next to the tangent lines, but just a reminder that a slope of, for example, -2 should be significantly steeper than the slope of -1. So here when I compare the slope of -2 to the slope of -1, they're significantly different, with the slope of -2 being slightly steeper. Alright, let's move on to part B. Use the slope fields for the given differential equation to explain why a solution could not have the graph shown below. So think about this. So based on this slope field that you just drew, or you figured out in 5A, why can't this be the solution? Why can't this graph be the solution to that slope field? So once again, pause the video and think about that. Okay, so hopefully while you were thinking this through, you might have noticed that the graph for 5B has a positive slope. So m is positive. And then it has a negative slope. So m is negative. I guess I should, since we are talking about calculus here, this is f prime, and this is also f prime. So the slope is the derivative. And notice that above the x-axis in quadrant 2, we have a positive slope. However, above the x-axis in quadrant 1, we have negative. In our slope field, all of the slopes all slopes are positive. Okay, so write down this explanation and make sure that you are organizing your notes a lot nicer than I am here, but I only have a limited amount of writing space on this screen, but this is pretty much a sample response to 5b. So the slope field has positive slopes for all coordinates above the x-axis, which implies no decreasing behavior for the solution y equals f of x above the x-axis. Now you could have worded this differently. It doesn't have to be word for word like this, so long as you hit some key points. And we'll keep working out problems like this to practice it. Alright, so part C, find the particular solution of y equals f of x to the given differential equation which contains the point 3 comma negative 4. So right up top, dy over dx is equal to 1 plus x squared over y is your differential equation. So let's go ahead and do that. So not too bad. Go ahead and separate by multiplying both sides by dx. And then you are also going to multiply both sides by y. So make sure you show that work, how you're separating the variables. I had students lose points on the homework because of that, or it was actually the classwork. And now you're going to integrate both sides. Okay, you guys pause the video and keep this going. Remember that there is an initial condition 3 comma negative 4, so we're going to be able to find the value for C. Okay, so pause the video, work this out. So far this isn't too bad. We have y squared is equal to 2x plus 2/3 x cubed plus c. So some of you guys might want to go ahead and take the square root of both sides, but before I make things any more complicated with square roots, I would say that this is a good point in the problem to solve for c. Okay, so remember that the point was, I believe, 3 comma negative 4. So 3 negative 4. We plug that in. So we plug in negative 4 for y. Okay. 3 for x. And go ahead and work that out to find your value for c. So we get c is equal to negative 8. And plug that in right here. So we get y squared is equal to, what was it? 2x plus 2/3 x cubed minus 8. And when we take the square root of both sides now, we get y is equal to plus or minus 2x plus 2/3 x cubed minus 8. Now the answer is actually the minus. So after all that, we just have y equals negative radical 2x plus 2/3 x cubed minus 8, and that's the final answer. And the reason for that, I'm going to go ahead and use decimals. So using decimals, you can see that the red is a positive 2x plus 2/3 x cubed minus 8 square root of it, so it's raised to the 1/2, and so that's in red. And in blue, we have the negative square root of 2x plus 2/3 x cubed minus 8, and we see that the initial condition of 3, negative 4 occurs on the negative side, on the negative part of this function. Okay? So that is why we only consider the negative radical 2x plus 2/3 x cubed minus 8 and not the positive. So including the positive would be actually wrong. Hopefully this helps. You went over a quick FRQ style problem, no calculator portion, that covers some topics from chapter 7. And that'll be it for this video.